broadcasting or the remote sensing application we consider, that communication will be taken into consideration in that particular rotating orbit. That is nothing but in this way we are going to do the communication with Earth and the satellite. So here basically we have three orbits that will be taken into consideration. First one will be low Earth orbit, and second one is medium Earth orbit, and third is the geostationary orbit. So here consider the three stationary orbits. First one will have LEO, second is MEO, and third is GEO. Based on the distance, there is nothing but inclination angle between the Earth and the satellite that will be taken into consideration, and that distance will be calculated. Based on that, we will be doing or communicating with the satellite. So this is the basic idea or behind the three orbits which we have in basic communication, satellite communication system. Now basically when we take or when we have two stations, right, when we are sending any information from sender to receiver or receiving antenna to the sender antenna, we will be having satellite in between. We have to communicate between two stations. So for that purpose, when we transmit any information from sender, let us consider this as sender or sending antenna. This is as the receiver antenna. So here when we send any information from sender to receiver, we have a satellite, right? So we have to communicate with the satellite. When we are sending information from sender satellite or sender station to satellite, we will be converting the frequency as uplink or uplink frequency. That is nothing but when we send any information from base station to the satellite, we have an uplink, and when we do communication from satellite to the receiver, we have a downlink. There is nothing but the satellite is acting like a repeater. That is nothing but when we transmit any information from transmitter to receiver, the frequency or the signal strength will be reduced. So when the signal strength is reduced, this should not happen. The proper signal will not be received when any signal strength or signal loss is happening. So for that purpose, we keep receivers generally. So instead of receivers, we use the satellite for sending any of the information between the sender and the receiver. So here the satellite is acting like a transponder. So transponder is nothing but it increases the signal strength, and then it will be transmitting the information from transponder to the receiver. So here it is converting whatever the frequency we are sending from sender to the satellite, it is converting into a uplink frequency. That is nothing but a frequency change is happening. So the frequency is changing. That frequency or that particular frequency is called as uplink frequency, and whatever the communication, generally we can say these are the information transfer between a sender or transmitting station to the satellite is converted into a uplink, or communication will be happening between a satellite and the base station is called as uplink, and the communication whatever is happening between a satellite and a receiver is called as a downlink. So basically the communication or the frequencies are converted at particular sender or base station and to the satellite, and from the satellite whatever the information is received, both the frequencies are different. So I'm not sending the same information. So here I have to improve the signal strength. For that purpose we are using the satellite. Satellite is nothing but generally a transponder. Transponder is nothing but generally it will be used to increase the signal strength of any of the information which is receiving from base station, that is receiver or sender, and another base station. Let us consider this as the secondary or base station 2. So when we talk about the satellite orbits, we have three satellite orbits based on the distance. That is nothing but from the Earth, what is the distance which is having, or the distance between Earth to a satellite. Based on the distance between these two, there is a classification of three types of stationary orbits. That is nothing but based on the trajectory or rotating path which is revolving around the Earth. That particular path only will be considering, and for that movement will be taken into account, and in that particular rotating in that particular trajectory only will all the orbits of satellites will be revolving. So based on the distance between the Earth and the orbit, there is a classification of three types of orbits. First one is LEO. When it comes to LEO, let me show you figures. Greater distance is given. So when it comes to low Earth orbit, it will be generally used for low-end applications. That is the distance between Earth and the LEO orbit will be generally 200 kilometers to 1200 kilometers, and coming to medium Earth orbit, we have the distance of travel will be 1200 to 35,000 kilometers, and coming to geostationary orbit, it will be about 35,000 kilometers. So based on the distance between Earth and a satellite, there is a classification of 3 types of orbits. So generally we will go for majorly the basic thing, or it is called as a geostationary. Why? Because the rotating satellite will be in a stationary position, so it is called as geostationary. So many applications will be dealing with the geostationary orbit. The major advantage with geostationary orbit will be, when we consider a geostationary orbit, the geostationary orbit will be covering the complete Earth region only with a minimum number of satellites. So that is why it is called as geostationary orbit, and it is predominantly used because only we have high-end applications, and also the complete entire coverage of the Earth will be covered with a minimum number of satellites, and it is having a distance of coverage will be above the 35,000 kilometers. The broadcasting on all the applications will be taking place in the particular region or particular trajectory will be covered, and the communication will be taking place between a satellite and the Earth. And also coming to the applications, we have direct broadcasting of television will be happening with the help of the geostationary orbits. Next, coming to the medium Earth orbit, it will be having a distance of 1200 to 35,000 kilometers, that is less than that of the geostationary orbit. Coming to the applications, we have high-speed telephone signals, and coming to low Earth orbit, we have it is above the Earth's surface, it will be approximately 1200